Hello and welcome back. Today we are going to be talking about pressure and Pascal's principle. First off, what is pressure? Simply put, pressure is the force divided by the area that force is acting on. If the force goes up, then the pressure also goes up. If the area goes up, then the pressure goes down. Pascal's principle uses the pressure equation and the fact that for a confined fluid, the pressure at every point within the fluid is the same. Therefore, if an external pressure is applied to a confined fluid, the pressure at every point within the fluid increases by that amount. This principle is commonly used, for example, in hydraulic lifts or hydraulic brakes. If we look at the case of a hydraulic lift, if we have 100 newtons of force being put on the end with a jack, and if that jack has a 0.1 square meter piston, it is a contained fluid, so the pressure is going to be the same on both ends. The lift end, if it has a 1 square meter piston, how much force will it lift with? If we solve this out here, it's going to lift for approximately 10,000 newtons. Go physics. The brake system pictured is not my favorite picture. The same principles apply and work the exact same way. A small piston with a normal sized force on the input, and a large piston with a huge force on the output. So let's go ahead and hit a couple of problems. For our first problem, which would you rather be stepped on? A 50-kilo lady in high heels with a heel area of 1 centimeter squared, or an oversized 500-kilo ape with a foot area of 200 centimeters squared? Assume they are both mean and put all their weight on the 1 foot. What are the pressures involved? So this is just a pressure problem. But which would I rather be stepped on? Neither, thank you very much. But if I had to pick my poison, the pressure of a heel, because I know she's evil and she's going to put all of her mass on just one heel. It's just going to be the force coming down on the heel divided by the area of that heel, or about 5 million newtons per square meter. That might hurt. Okay, what's my other option? My other option's an ape. That's about 500 kilograms of mass times gravity divided by 200 square centimeter area. It's not quite piercing. I don't think I'll die, but it's still going to hurt. I suppose I will be stepped on by an ape. Okay, another problem. Have you ever lifted a car with your finger? Thanks to Pascal, you could. We have a hydraulic lift that has one piston with a diameter of 1 centimeter and another piston with a diameter of 30 centimeters. A 1,000 kilo auto is over the large piston. How much force must be applied to the small piston to lift the auto? It's just Pascal. Force over an area is going to equal another force over an area. If we plug in what we know to this, we can solve for that first force required. Simplify this a bit. Let's punch it into the calculator. 11 newtons. Yeah, if you can push about a kilo or so with your finger, you can probably lift a car. So thank you for watching. Please remember to check as you learn for the remainder of your assignment.